For our project, we decided to look at the physics concept of acceleration on an incline, which is present in our everyday lives whether we realize it or not. Some examples of this include water slides, wheelchair ramps, and escalators.
Specifically, we wanted to analyze the acceleration of two different objects. We decided to look at the accelerations of a cart and a smooth ball. We had placed a track on a metal rod clamped to a stand which had an angle indicator attached to it.
As can be seen in this image of the cart, the forces acting upon it are the weight force, which is pointing directly downwards, and the normal force, which is perpendicular to the track. In the image of the ball, it is seen that it also has weight and normal in the same directions as the cart, however, also has static friction pointing opposite of motion between the ball and the ramp, which will be explained later on. Using the videos of the cart and the ball, we were able to find the velocity versus time graphs for each object.
For the velocity versus time graph of the cart, it was shown that the experimental acceleration for the cart was 2.94 meters per second squared. Using the equation for the theoretical acceleration of a equals g sine theta using 15 degrees as theta, it was found that the theoretical acceleration for the cart was 2.54 meters per second squared. Using these two values, we calculated the percent discrepancy to be 15.7%.
For the velocity versus time graph of the ball, it was shown that the experimental acceleration for the ball was 1.64 meters per second squared. Using the equation for the theoretical acceleration, taking into consider the static friction, 5/7 g sine theta, using 15 degrees as theta, it was found that the theoretical acceleration for the ball was 1.81 meters per second squared. Using these two values, we calculated the percent discrepancy to be 9.4%.
It was found that the ball had a lower acceleration than the cart due to the static friction acting upon it. The reason there was static friction upon the ball was to cause it to rotate and begin rolling down the track. The static friction applies a torque to the bottom of the ball, which is in contact with the track at every moment to begin rolling, which in turn causes it to have a lower acceleration in comparison to the cart, which does not have static friction acting upon it.